So, as I told, before commencement of the next topic, which is dielectric constant, we must know in detail about the additive properties, colligative properties, and constitutive properties. So let us see about what exactly colligative properties mean, because we have already learned, tried to understood about the additive property, constitutive property. We have taken the examples of that also. Example of mass we have taken, weight we have taken for the additive property. Examples of optical rotation, specific rotation, molar reflection uh, are coming under the constitutive property. Now comes the colligative property. Colligative property is somewhat different than additive and constitutive property. When we say additive or constitutive, we are going into the details of a molecule. So the molecular details is needed to understand how to get the properties belonging to additive properties, properties belonging to constitutive property. But when we are going towards the colligative property, we need to consider the number of molecules, number of participants involved in that state of matter, number of molecules. So, in total, what we can say, just like in our constitutive property, if the structure of a molecule, if the structure within a molecule will get changed, it will going to reflect onto the magnitude of any of the constitutive property when the structure will get changed. But when we are dealing with colligative property, the change in structure does not affect or influence the magnitude of colligative property. That is the most differentiating point. So, which thing influencing the magnitude of colligative property then? It is their number. If the numbers of participating molecule in that phenomena will get increased, the magnitude of the colligative property will be increased or decreased. It may be by both the ways, but it will going to alter the physical colligative properties magnitude. So, when we say that colligative property is affecting to a particular chemical, influencing a particular chemical, we are always considering non-volatile substance. Now, non-volatile substance are the substance which are having lower vapor pressure. At room temperature, it does not vaporize generally. Its boiling point will be somewhat higher. It does not vaporize so much quickly. It does not evaporate so much quickly, which is the identity of the non-volatile substances. So here, colligative property can be well explained with the help of non-volatile substances or associated with. Then comes the next, which are the examples of colligative property. From the examples only we can able to learn the meaning of colligative property along with example. Vapor pressure lowering, one example, boiling point elevation and freezing point depression. Now you have to consider all these three one by one. When we consider vapor pressure lowering, means this process or this phenomena totally coming under the colligative property. When we say boiling point elevation, means what we need to consider? We need to consider the original solvent. Original solvent along with its original boiling point. Say for example, take the example of water. What is the boiling point of water? Anyone?
100
100
degrees
degrees
Celsius.
Celsius.
100 degrees Celsius.
100.
Yeah. What is the freezing point of water?
Below 0 degrees Celsius.
0 degrees Celsius. Correct. We have to stuck to boiling point. Okay. Now original uh, boiling point of water is 100 degrees Celsius. Now with this phenomena, its boiling point will now get raised from 100 degrees Celsius as the original. It would get raised by 1 degree, so that now the boiling point of water can be recognized or can be considered as 101 or 102 or 103. Means what we have noticed? We have noticed that the boiling point of the solvent got raised by some degree due to some factor, due to something which we have added in that solvent. Okay, so this thing change the original boiling point of solvent, and this whole process or whole phenomena should be considered as an example of colligative property. Similarly, when we are taking the consideration of freezing point, just now you told that freezing point of water is 0 degrees Celsius. Now, with the presence of something, with the presence of some solute, or with the presence of some content, with the addition of some content, the original freezing point of water, which is 0 degree Celsius, now it got lowered. Now the water will freezes at -1, -2, -3, -4, like that. Its freezing point, original freezing point, got depressed, lowered, lowering of freezing point. But it would be less than 0. So this example can be considered uh, as an example of colligative properties. Okay. The first we will see decrease in vapor pressure. Earlier I told something about the vapor pressure. Now my first question is, what is vapor pressure? Anyone can give me the answer of that? To whom we should call a vapor pressure? What is meant by vapor pressure with your understanding? Yes, anyone? Anyone? What is meant by vapor pressure? No one. At
It
least
is
you
a
can try.
tendency of a material to change into gaseous form.
Uh, Actually, it is not vapor pressure. It is a vapors that is getting generated. I am asking about the what is mean by vapor pressure. To whom we should call a vapor pressure? Yes? Anyone? No one. No one knows what is by vapor pressure. Anyone?
No.
It is
It
exalted
is
by
the
a gas.
Yes? Yes?
The pressure which is exerted by a gas in equilibrium of solid or liquid.
Yes. Nearby. Good. So basically, when we are taking a liquid in a beaker, and then when we are heating it, obviously the liquid will get converted into vapor, and the vapor which is getting generated when they are uh, although obviously they are the gas molecules which is getting generated, they will definitely going to fall onto the walls of the container or onto the wall of the lid. So obviously a gas molecule is having more energy than the liquid molecule, but they are gas molecules. And obviously if they are having more energy, they are going to, they already escaped from the liquid bulk, they are having more energy, so they are going to exert some pressure onto the walls of the container. And when the pressure exerted on the walls of the container, onto the lid of the container, that pressure we can recognize as vapor pressure. Okay, this would be additional requirement that it should be an equilibrium and all these things. Okay, but basic in a layman term, you can say the uh, pressure exerted, gas pressure exerted on the walls of the container, that is called the vapor pressure. Okay, the pressure exerted by vapor, that is in equilibrium with its liquid in a closed system. Whenever we are talking about the closed system, it is covered with lid. A solution with a non-volatile substance, one that is not easily vaporized, contains a lower vapor pressure than a pure solvent. When we dissolve salt or sugar in water, the molecules or ions are surrounded by water molecule which trap them into the solvent. Therefore, pure molecules will contain enough kinetic energy to escape the vapor of the liquid. To escape the vapor of the liquid. Okay. We are here talking about the non-volatile solute. And non-volatile solute are, it may be sugar, it may be salt, or similar molecule just like that, which do not have tendency of escaping bulk of the liquid. That is the non-volatile solute. When we try to dissolve, when we try to dissolve the salt or sugar molecule, it would get dissolved into the liquid, and it occupies a space which is present in between solvent molecule. It occupies the space. Okay? It occupies the space which has been provided by the solvent molecule, but it don't leave the bulk of the liquid. It remain over there into the bulk of the liquid, making the whole system as salt water or making the whole system as sugar solution. And now sugar or salt becomes a part of liquid bulk, that I want to say. And when it became a part of the liquid bulk, it will, it is going to show a combined effect on the boiling point of that water. Now, what you have to consider? Okay, what you have to consider? In the next example, we are going to take the boiling point of water and elevation of boiling point. Here, decrease in vapor pressure. Here means what you have to say. Whatever the vapor pressure the water is having, when certain solute is being added into the original water, the original vapor pressure will get decreased. Now it would come at the water would not get evaporated easily. The temperature at which the water can get evaporate easily, at that temperature it will not show further any kind of vaporization. Say for example, at 60 degrees Celsius, if the vapors are coming out with a rate of 5, say for example 2 gram per minute, for example. Okay, then after the addition of sugar into it, now the vapor will not come out at 60 degrees Celsius with a specified rate. It may come, either it may not come, or it may come with lesser rate of generated vapor. Got it? And why it is why it was happen? Due to presence of uh, either salt or the sugar into the water. So the presence of this made water less vaporizing, less evaporating. Why it is happen? Due to presence of salt or sugar. Basically, they are the non-volatile solute. The non-volatile solute occupies the space in present in solvent, and this when when this non-volatile solute occupies the space in between solvent molecules, they become a part of it. Now further, the temperature which is required to elevate at a particular extent, we need more temperature for the generation of vapor. It can get easily explained or uh, more get simplified in the next example. Boiling point elevation. Now for that, what you need to consider? First of all, we will read the difference in temperature at which the vapor pressure of the liquid phase equals the atmospheric pressure. That is the boiling point. Equals the atmospheric pressure. What is by atmospheric pressure? Anyone? Anyone? What is by atmospheric pressure? We are very much familiar with the atmospheric pressure. But let me know how many of you are exactly knowing what exactly practically the atmospheric pressure is. Anyone? Yes. We are always saying that one atmospheric pressure is always be there at normal temperature pressure. But my question is, what is mean by atmospheric pressure? Anybody can explain? Anyone? Yes. Be fast, be reactive. I ask to all. Anybody can reply. What is mean by atmospheric pressure? You must understand that. Yes.
Pressure exerted by atmosphere.
Pressure exerted by atmosphere. Can you elaborate that much more? What you understood?
um, the pressure which is in atmosphere, uh, the atmosphere itself exerts pressure, so it is known as atmospheric pressure.
Okay, let me explain that. Let me explain. We have taken a beaker containing water. It may be 100 ml water. Okay. Now beaker is on table. Now beaker is having certain diameter. Beaker is having certain diameter. And what we need to consider? We need to consider the air, or in total the whole atmosphere. The whole atmosphere above the only above the beaker. That's it. Means from the starting point. Which will be the starting point? It is a surface of liquid. It is a surface of liquid which is there in the beaker. Now from that surface, you have to go upward until you reaches last point of the atmosphere. Last point of the atmosphere. So whatever the column, cylindrical column, you can say, whichever the cylindrical column, imaginary column that you can imagine well above the beaker until the last atmospheric point, that much quantity of atmosphere, that much quantity of air, that much quantity of atmosphere exerting a pressure onto the liquid in the beaker, that will be 1 atmospheric pressure for that liquid. Means it is a 1 atmospheric pressure exerting the pressure onto the liquid contained in the beaker. Now you got the understanding? Even for us, we are also in pressure of this atmospheric pressure. When we are standing, say for example our head, if you can draw an imaginary column above our head, circular column, up to the last point of the atmosphere, well above, and whatever the content of air will be there in combined, whatever the mass, this mass is going to exert the pressure downwards due to the gravity, and whatever the pressure which will get exerted by this contained by this mass which we are imagining from our head surface up to the last point of the atmosphere, that much quantity of mass that we are imagining, that is called the 1 atmosphere pressure exerting on our head. Okay, so this is called the atmospheric pressure. The difference between a difference in temperature at which vapor pressure of the liquid phase equals the atmospheric pressure, that is called the boiling point. Means now you have to imagine the beaker containing liquid. We are boiling the liquid. We have started the boiling from 25 degrees Celsius, that is room temperature. Then it is go on elevating, and then when it matches with the atmospheric pressure, then at that point the temperature at which the liquid starts boiling, when it equals the atmospheric pressure, that temperature is called as boiling point of the liquid. Okay, when a non-volatile substance is added, we are going to explain the elevation in boiling point. Now for that, which is the colligative property, for that you need to imagine one beaker containing water and another beaker contained with salt solution or sugar solution. Okay, 2 beakers are there. One is simple water, second beaker contained with sugar solution, means water plus sugar. Okay, now you have to imagine that one beaker is contained with water, another beaker contained with sugar solution, means the water plus sugar.
Not audible.
Hello, anybody want to say something? Hello. Yes. So I am continuing. Am I audible? Am I audible? Hello. Am I audible to all of you? Hello. Hello. Now am I audible to all of you?
Yes, sir.
Yeah. So now let us see what is meant by elevation of boiling point as an example of colligative property. For that, you need to imagine one beaker contained with simple water, another beaker contained with water plus sugar, means sugar solution. Now for that, additionally, you need to imagine that the sugar solution just contained with 10 molecules of sugar only. 10 molecules. Okay? Means the second beaker is contained with water and sugar, but sugar molecule is are 10 only. Okay? Now heat both of the beaker. Heat both of the beaker. First beaker contained with water, second beaker contained with sugar solution but contains 10 molecules. Okay? Now you will notice that at 100 degrees Celsius sharp, at 100 degrees Celsius sharp, the vapors are constantly coming out from the first beaker containing pure water. Vapors are constantly coming out from first beaker containing pure water, which is at 100 degree Celsius temperature. But in second beaker, which is contained with sugar, 100 molecules of sugar, 10 molecules of sugar and water, you will notice that its boiling point, the boiling point of this water, the boiling point of second beaker, the boiling point of water contained in second beaker. Now the boiling point reaches at 101 degrees Celsius. Means what? At 101 degrees Celsius, the vapors coming out constantly. Earlier, when 100 degrees Celsius was reached for second beaker, the vapor does not came out constantly, so that we cannot call it as boiling point. We can call it as boiling point whenever the vapors came out regularly. Vapor comes out regularly, and which is happening with second beaker at 101 degree Celsius. Now you got the difference. That the boiling point of first beaker water, the boiling point of first water is 100 degrees Celsius, whereas the boiling point of second water, who will boil? Obviously solvent will only boil. So boiling point of second water is 101 degrees Celsius. So what will happen? The boiling point of the water got raised, and why it was why it is happened? Due to presence of 10 sugar molecule in it, because of presence of 10 sugar molecule into the water. It is happening with second beaker. Okay. Now what we can do? We will add another 10 sugar molecule in the second beaker. Another 10 sugar molecule into the beaker, second beaker. Now further, first of all, cool it down and then further elevate the temperature. supply the temperature. You will notice that now this time with the presence of 20 molecule, now the constant coming of vapors begins or occurred at 102 degrees Celsius. Now what you have noticed? You have noticed that now the boiling point of water, again the solvent is same. The boiling solvent is water only, but it got raised. The boiling point of water got raised by 2 degrees Celsius. So what would be the factor? Which is the factor? It is the presence of sugar molecule. Earlier it was 101 due to the presence of 10 molecule. Now it is 102 due to the presence of 20 molecules. Similarly, when we go on adding 10 molecules into the water containing second beaker, okay, which is in second beaker, the boiling point elevation also got raised with 1 degree, okay, and this is called the boiling point elevation. Now I am going to conclude this phenomenon. Why it is happening? It is so obvious that this is happening due to presence of sugar molecule. As we go on increasing the sugar molecule, we are noticing that the temperature or the boiling point of the second beaker or the water of second beaker is getting raised. So originally what is happening? The water boiling temperature, boiling point of water is getting raised due to addition of non-volatile solute. So when non-volatile solute got added, what is happening? Now come to first. When we have added the 10 molecule of sugar, whatever the heat which we are supplying, it we can say it is insufficient to boil. It is insufficient to boil the 100 ml of water plus additional 10 ml of sugar molecule. 100 degrees Celsius is insufficient. So, in that case, we were needed to supply some more amount of energy so that water starts to boil or water starts boiling. I am talking about the second beaker. So we came to know that at 101 degrees Celsius with 10 molecular sugar and our water, we got the boiling point. Now when further another additional 10 molecule of sugar were added, means the bulk got increased. Original water is same, but the additional solid molecules got increased, sugar molecule got increased, it got double, so that it creates the effect onto further elevation of boiling point. Got it? So that what we have noticed that further the amount of heat which we have supplied earlier and reach up to 101 degrees Celsius, now it becomes insufficient. It becomes insufficient for the boiling. So what we did?
Not audible.
Now I am audible.
Yes, sir.
Yeah. So further, when we are supplying, we needed to supply much more amount of heat if we have added the additional 20 molecules. Then we got the boiling point at 102. Further, we have added another 10 molecules. So we have 30 molecule of sugar, and then again we find that we don't have enough amount of energy for the occurrence of boiling. So we have raised the energy so that the water can get boiled, water can get evaporated, constant vapor should come out. And then we notice that with every addition, more and more numbers of molecules, if we are accommodating in water, more and more or the elevation of boiling point is occurring. So, to conclude this point about the colligative property, I must say that increase in number of molecules in the bulk of the solvent will going to increase the boiling point of that solvent. So from 100 degrees Celsius, due to the accommodation of uh, solute molecule, elevation of boiling point will occur, and that is called the elevation of boiling point phenomena, which is an example of colligative property. So from this example, what we can conclude, what we understood, colligative property is dependent upon number of molecules participated in the phenomenon. Got it? So colligative property does not interested in structure of molecule. Instead of sugar molecule, if you are added the salt molecule also, it would not bother. It will definitely going to raise the boiling point. It may be in a somewhat different manner. It may be in a somewhat different rate or different extent, but it would going to elevate the boiling point because something has been added in the water. Got it? No matter which matter we have added, it is just a number of molecule which is the interesting point. Matter of interest over here. Number of molecules. We can add something else also, but keep in mind it should be having volatile or non-volatile. Yes, it should be non-volatile in nature, non-volatile type. Accidentally, if we have added the volatile component, then what will happen? Firstly, that volatile component will get vaporized. It will not participate in the bulk of the water or bulk of the solvent. So how come the evolution of boiling point will occur? It will not occur. So, so that to understand the colligative property, we must accommodate the non-volatile solute along with solvent. Got it? So this is the elevation of boiling point. Similarly for the freezing point also. Now you got the understanding of the elevation of boiling point. When 100 ml beaker, 100 ml water in first beaker, 100 ml water in second beaker. Now decrease the temperature. You will notice that at 0 degrees Celsius, the first beaker, which is contained with pure water, it would get freeze. And in the second beaker, contained with 100 ml water plus 10 molecule of sugar, you will notice that it will not get freeze at 0 degrees Celsius. Rather, it will get freeze at minus 1 degree Celsius. So that is the difference of uh, presence of sugar. 10 molecule got increased, 10 additional molecule came in the path, came in the bulk, and obviously they are going to contribute into the physical property of water. And what they are doing, they are decreasing the freezing point of water in this manner. So that is called the freezing point depression. I hope you understood the boiling point elevation as well as freezing point depression. Similar example are osmotic pressure, vapor pressure lowering are also there. Anybody can tell me what is by osmosis? Anyone can tell me what is by osmosis? You should be interactive. What I told earlier, you are having the marks. You should be interactive. Osmosis, I ask. What is by osmosis? And how it is differing from the diffusion? Anyone?
Sir, osmosis is a transfer of solvent from a lower to higher concentration through a semi-permeable membrane.
Transfer of solvent from lower to higher concentration. All the things are correct, but only you got you can say wrong with from lower to higher concentration, and you got something confused. Yes, can you correct? Can you correct? You want to correct it? Yes, I am challenging yours. What is the osmosis? Simple, simple phenomena asked. It may be,
The concentration to
How?
lower concentration until the concentration become equal on either side of the membrane.
yes, anybody else? Somewhat, somewhat you are reaching nearby. Yes. Next, anyone?
Sir, through a sir
Osmosis
through a
is the
semi-permeable
एक
membrane.
एक एक
spontaneous
एक 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 सांगा. Anyone?
of a solvent molecules through a selectively permeable membrane from a region of higher concentration
To the region of lower concentration. Is it? Now let me clarify your doubts. Let me clarify. Be with me. I am going to explain the osmotic and osmotic pressure. Be with me. Hardly 5 minutes I will take, but your concepts will get clear. 100%. Be with me. Now how osmosis is being associated with diffusion. That also you need to understand. For that again, you need to imagine. You need to imagine a vessel, a vessel contained with water separated with a semi-permeable membrane, so that two chambers will be there. Two chambers will be there. Now understand, huh? This would be very helpful for you forever. Again, I am repeating: vessel contained with water, and that water will get separated by a semi-permeable membrane. Semi-permeable म्हणजे काय? सेमी परमिएबल. सेमी म्हणजे काही किंवा अर्ध, म्हणजे कोणाला तरी परमिएट करतं तर कोणाला करणार नाही. सेमी परमिएबल, got it? Semi permeable membrane. Now a vessel is there, contain water and separated by a semi permeable membrane. Okay. Now what you have to do? You have to add 1 drop of or say a sugar in first chamber, left hand side chamber, sugar in first chamber. You don't have to add the sugar in second chamber, only in first chamber you have to add the sugar, some sort of sugar, whatever the quantity, that is not the matter. Sugar in first chamber, that is left hand side chamber. Now obviously it is so obvious that first chamber is contained with sugar and water. Second chamber is not contained with sugar, only it contains water. Got it? Now, this first chamber, now you have to assume first chamber is contained with sugar and water. Second chamber do not contain with sugar, only water. Okay. Now first consider diffusion. Diffusion. What is in by diffusion? Not to get confusion, be separated properly. Understand. Very, very important to understand further things. And keep in mind forever in your mind. First chamber. Let us understand the diffusion first. Then we will come on to the osmosis. Diffusion. Keep my words with you. When we consider diffusion, we need to consider the concentration of solute in two chambers. Bus. Although in both the chamber, solute may be there. Okay, in both the chamber. After some time, the sugar will get transferred into the second chamber also. So here we need to understand the diffusion, we need to consider the concentration of solute only. So what we understood? We understood that in the first chamber, concentration of solute is high, and in the second chamber, concentration of solute हा सॉल्व्हंट बद्दल मी अजूनपर्यंत बोललेलो नाही. concentration of solute is low. So in first chamber concentration of solute is high, in second chamber concentration of solute is low, so that concentration gradient exists. High concentration in first chamber, low concentration in second chamber. Due to this difference, due to the presence of difference, the solute migrate from its higher concentration. It word महत्वाचा आहे. It म्हणजे solute. The solute molecule will migrate from its higher concentration region towards its lower concentration region. Am I clear now? Is it clear? Yes or no? Is it clear? Yes or no? सांगा पटकन.
Yes, sir.
हाँ. We are learning diffusion, and we are considering solute concentration in both the chamber. That's it. Okay. When we need to understand or express the diffusion, we need to consider the concentration of solute only in both the chamber, where it is higher, where it is lower, so that from the higher side it got transferred to the lower side. Until what? Until which stage it would get transferred? Until the stage when the concentration of both the solute in both the chamber will come equal. Up to that point, it would remain to do the migration. It would remain to get transfer from its higher to lower, higher to lower, higher to lower, until it equilibrates, until equalize, until concentration of both the chambers of solute equalizes. त्या पॉइंट पर्यंत त्यांचं मायग्रेशन चालू राहील, हायर टू लोअर, हायर टू लोअर. Because concentration difference only is the driving force for the diffusion. हे झालं diffusion. आता येऊया osmosis. It is merely similar now. आता very what you call concisely I am telling. Whenever we need to consider the osmosis. Now again come reverse back. Okay. We are having the one vessel containing water, and in the left hand side chamber sugar solution. After some time, some sugar solution, some sugar molecule will get transferred into the second chamber. Okay. Now what we are having? We are having the two chambers, left hand side chamber with higher concentration of sugar, right hand chamber with lower concentration of sugar, but both the chambers are having solute and solvent. In the second chamber, the solute concentration is lower. In the first chamber, which is left hand side, solute concentration is high. I think you got the thing and you are with me. Now I am going to explain the osmosis. What is by osmosis? To understand the osmosis, we don't have to consider the solute concentration. Instead, we need to consider the solvent concentration. Again I am repeating. we need to consider the solvent concentration. सॉल्व्हंट मॉलिक्यूलचं कॉन्सन्ट्रेशन बघायचं आहे. ओके, कसं बघायचं? इन द फर्स्ट चेंबर higher concentration of solute is there, so obviously in the first chamber lower concentration of solvent will be there. Again I am repeating, in the first chamber where there is solute concentration is higher, obviously there will be lower comparatively lower solvent concentration. And in the second chamber where there is lower solute concentration, obviously the solvent concentration would be more. In the second chamber, number of solvent molecule will be more, and in the first chamber, number of solvent molecule will be less. So how the concentration gradient? The concentration gradient is like this. Second chamber, solvent concentration is higher. First chamber, solvent concentration will be lower. Second chamber, solvent concentration higher. First chamber, solvent concentration lower. So that due to the existence of difference of solvent concentration, solvent, I am underlining this word, solvent will try to migrate from its higher concentration region towards its lower concentration region. Means practically what will happen in osmosis, solvent from the second compartment, second region, second chamber will migrate towards the first chamber. And up to which point it will get migrated? Until the equilibrium. Very similar. Because due to the existence of this concentration gradient म्हणजे डिफरन्स, या दोघांच्या चेंबर मधल्या कॉन्सन्ट्रेशन मधला डिफरन्स असल्यामुळेच द solvent molecule will migrate. Solvent molecule will migrate, and due to the migration of solvent due to osmosis, this phenomenon is called as solvent drag. Solvent drag, got it? And whatever the solvent that will get dragged from second chamber into first chamber, and due to that the elevation of solvent will be there in the first chamber, and due to the elevation a pressure would get exerted onto the walls of the first chamber, and whatever the pressure that would get exerted on the walls of the first chamber due to solvent drag from second chamber, that pressure is called as osmotic pressure. Osmotic pressure. So this is all about the osmosis, where we need to consider the concentration of solvent considering both the chambers, and in diffusion we need to consider the concentration of solute in both the chamber. So I hope you understood the difference very well in between diffusion and osmosis. Have you got that? Have you got understood? Yes or no? Yes or no? Somebody should tell.
Yes, sir.
Okay. If any doubt you are having, tell me the doubt. So with this we have understood about the colligative property, additive property, let me take the attendance now.